Hey guys, in today's video we are going to be talking about comparing fractions. Before we start, I would like to quickly cover some definitions. For a fraction, such as this one over here, 2 over 3, the top number has a special name. We call that the numerator, and the bottom number we call the denominator. So let's get into some examples. Question 1 asks us to simplify the following fraction, 20 over 24. Now, this is an important step in allowing us to compare fractions, as we will see later on. So, to simplify this fraction, we would need to find the highest common factor for these two numbers. Now remember, the highest common factor is the largest number that fits into these numbers. So the highest common factor of 20 and 24 is 4. So we divide 20 by 4 and we then divide 24 by 4. As you can see, we've divided both numbers, both the numerator and the denominator, by the highest common factor. So 20 divided by 4 is 5. 24 divided by 4 is 6. And we can see that this fraction cannot be simplified any further, and it is therefore in its most simplest form. What some of you may have done is you would have realized that both 20 and 24 could be divided by 2, in which case you would have gotten the fraction 10 over 12, right? And you would have noticed again that you can divide both 10 and 12 by 2 once again. And if you did that, you would then get 5 over 6. So you arrive at the same answer. It is slightly longer. However, if we had realized that 4 is the highest common factor of these two numbers, we could have just used that and we would get to the final answer a lot quicker. For question number 2, we are once again asked to simplify this fraction, 25 over 45. Once again, we need to try and find the highest common factor between 25 and 45. There's a bit of a trick here because we know that the only numbers to go into 25 are 1, 5, and 25. And we can see that 25 does not go into 45. So our highest common factor for 25 and 45 is going to be 5. So we can then divide both the numerator and the denominator by 5. 25 divided by 5, that gives us 5, and 45 divided by 5 gives us 9. And we can have a look at that final answer, 5 over 9, and see that it cannot be simplified any further. So therefore we know that this is in its simplest form, and that is our final answer for question number 2. Question number 3. And once again, we are asked to simplify the fraction 9 over 18. Now, what some of you might do is you will see that the number 3 goes into both 9 and 18, which is correct. But there is another number which is actually the highest common factor. As we can see, 9 goes into 9, obviously, and a 9 also goes into 18. Therefore, our highest common factor is actually 9. So, we divide the numerator by 9, and we divide the denominator by 9, and this will give us 9 divided by 9 is 1, 18 divided by 9 is 2. So, our final answer is a half, and this can't be simplified any further. What you might have done is if you had divided by 3, you would say 9 divided by 3, and that will give you 3. Then you might have said 18 divided by 3, and that will give you 6. This fraction, 3 over 6, is not in its simplest form because we can divide the numerator and the denominator by 3 once again. So if we had done that, 3 divided by 3 is 1, and 6 divided by 3 is 2. So once again, we get to the same answer, but by dividing by the highest common factor, which was 9, we arrive at our final answer a lot quicker, and it is a slightly more correct procedure. For question number 4, we are asked to determine the value of x in these equivalent fractions. So to make these fractions equivalent, we need to make the denominators the same. So we can see that if we multiply 8 by 2, we will get 16. So what we can do is multiply by 2, and whatever we do on the one side, we do on the other. So whatever we do at the bottom, we must do at the top. So we're essentially multiplying this whole fraction by 1, right? Because remember, 2 over 2 is just 1. So if we multiply the top by 2 and we multiply the bottom by 2, we're not actually doing anything. So we're not really changing the fundamentals of this fraction. So 3 times 2 gives us 6, 8 times 2 gives us 16. And this equaled x over 16. So now our denominators are exactly the same, which is what we wanted. Now we can see that our numerators give us that x equals 6. And that is exactly what they asked us to find. They asked us to find the value of x, and we just did that. For question number 5, once again, we need to find the value of x. To do that, we need to make sure that these denominators are equal. That way we will have equivalent fractions and we can easily find our value of x. So if we need this denominator to be 3, what are we going to divide by? We're going to divide by 6. We will therefore divide the 30 by 6 as well. Now we can say that x over 3 equals 30 divided by 6 is 5, 18 divided by 6 is 3. Therefore, we can say that x equals 5. Because our denominators are the same, our numerators can then be compared, and because we're told that they are equal, we know that x equals 5. And that's our final answer for question number 5. For question number 6, we are asked to compare these two fractions. Now remember, when we're comparing fractions, we need to determine whether the one is greater than the other, or less than the other, or if they are equal to each other. Now, once again, if we want to compare fractions, we need to ensure that their denominators are the same. So to do that, we could multiply that by 2, because we know that 2 times 2 is going to give us 4, and therefore our denominators will be the same, right? Another way to do this would be to multiply this fraction by this denominator and multiply this fraction by that denominator. And this is the procedure, or rather the method, that I would like you guys to make use of. So let's do that. We multiply there by 4, and we're going to multiply this by 4 as well. And we then multiply this by 2, and that by 2. Therefore, we'll have 6 over 8, because remember 2 times 3 is 6, and 2 times 4 is 8. Now for the second part, 1 times 4 is 4, and 2 times 4 is 8. And can you see now that we now have the same denominator at the bottom, right? So now it is possible for us to make a comparison. To make this comparison, since our denominators are the same, we just need to look at the denominator, at the numerator, and we can see that 6 is larger than 4. Therefore, the fraction 3 over 4 is larger than 1 over 2, which you guys should know. 3/4 is larger than a half. Question number 7 once again asks us to compare these two fractions. So let's use the same method that we used in the last example. We're going to multiply this fraction by the denominator of the other fraction. So we multiply by 6 and we multiply by 6. Next, we're going to multiply this fraction by the other denominator. So 5 times 8 and 6 times 8. This then gives us 30 over 48, because 6 times 8 is 48, and 5 times 8 is 40, and 6 times 8 is 48. Now, since we have the same denominators for both fractions, we can look at the numerators, and we can see that 40 is greater than 30, right? Since we're looking at the numerators. Therefore, the fraction 5 over 6 is larger than 5 over 8. For question 8, we are asked to compare the fractions 1 over 6 and 1 over 5. So we multiply these two by the denominator of the other fraction, which is 5, and we multiply this fraction, both the numerator and the denominator, by the denominator of the other fraction, so we multiply by 6. Therefore, 1 times 5 gives us 5, 6 times 5 gives us 30, 1 times 6 is 6, 5 times 6 is 30. Now we can see that since our denominators are the same, they're both 30, we can compare, and because 6 is greater than 5, we can say that 1 over 5 is larger than 1 over 6, or rather 1 over 6 is smaller than 1 over 5. For question 9, we're comparing 1 over 4 and 2 over 8. Now, there is a shortcut to this. I could multiply that by 2 and that by 2 because we know that 4 times 2 is going to give us 8, right? But just to get you guys into the practice of multiplying by the denominator of the other fraction, we're going to use the full method. So we can multiply this by 8 and this by 8, and we will multiply this by 4 and this by 4. Then 1 times 8 is 8, 4 times 8 is 32, 2 times 4 is 8, and 8 times 4 is 32. Now our bases are the same, we can compare numerators, and 8 equals 8, right? It's the same number. Therefore, 1 over 4, or rather a quarter, is equal to 2/8, right? These two fractions are equal to each other, they are equivalent. For question number 10, we are asked to determine the value of x for these fractions. So as we did in the previous examples, we need to make sure that our denominators are equal. To do that, we can see that we need to turn this 4 into a 12. And to do that, we are going to multiply by 3, since 3 times 4 gives us 12. And whatever we do at the bottom, we must do at the top. Therefore, we are going to have 3a times 3 gives us 9a, and 4 times 3 gives us 12. This then equals x over 12, And since our denominators are the same, 12 and 12, we can then compare our numerators. So we can say, therefore, x equals 9a. And that is our final answer for question number 10.